milk on the fridge?
All right, y'all. We're going to look at creating equations for linear functions. Okay? Got a variety of situations I'm going to throw at you, but we're going to try to find in the linear equation for all of them. But first, before we begin, you need to be familiar with trying to find linear equations in slope-intercept form and in standard form. The basic form of these is y equals mx plus b, okay? M referring to slope, b referring to the y-intercept. The other form is standard, which is ax plus by equals c. So looking at these three different forms, I'm going to try to create all of them today, or rather, both of them, okay? So looking at a graph here, we're going to try to create both forms from this graph. Well, looking here, I have a y-intercept of 3, so I can easily create slope-intercept form. Y equals something something plus 3. Looks like our graph is going down 1, 2, 3 over 1, 2. It's going down 3 over 2. That's our slope. Down 1, 2, 3 over 1, 2. Okay? But how do we write that in standard form? This is slope-intercept form. How can we write it in standard form? Well, we just need to get the variables on one side and try to get rid of the fractions. So first, we're going to add 3/2 x to both sides. I got y plus 3/2 x equals 3. I'm going to multiply both sides by 2. Why? Because that 2 will reduce this denominator to getting 2y plus 3x equals 6. So there we have it. We have the linear equation in standard and slope-intercept form. The beautiful thing is, both of these forms are equivalent. Let's keep going right along here. Okay, now we're trying to find the equation. If we're given standard form, can we create slope-intercept form? Well, yes, we can. All we have to do to create that slope-intercept form from this standard form is we have to isolate the y. Okay? We're going to do subtract 9x from both sides. I get 2y equals negative 9x minus 2. Divide both sides by 2. I get y equals negative 9 over 2, x minus 1. This is slope-intercept form. It is equivalent. My y-intercept is 0, negative 1. And my slope is negative 9 over 2. Great. Let's keep going right along here. All right. We're going to try to find standard form if we're given it in slope-intercept form. Okay? So what we're going to do is we're going to try to get the variables on one side. We're going to subtract 7 over 5x from both sides. Okay, so now I get y minus 7 over 5x equals negative 5. Multiply both sides by 5. I get 5y minus 7x equals negative 25. And there you have it, standard form. These forms are both equivalent. Okay? Now, what if we're not given one of the forms, but we need to find the standard form and the slope-intercept form, like this? What if I was given a point and the slope? What are we going to do? Well, here's what we're going to do. We know that the slope is 1, but what we really need to do is find the y-intercept. And what we can do here is we have an x, comma y. We can use this x, comma y to find the y-intercept. The y is negative 2. The x is 5. Now we just need to solve for b, which is the y-intercept. We're going to do some inverse operations. We find that the y-intercept is actually -7. So our slope-intercept form is y equals 1x minus 7. Now, if I want to put this in standard form, all I need to do is subtract x from both sides, and I get y minus x equals -7. We have slope-intercept form, and we have standard form. What if we're given the slope and the y-intercept, like we are here? So now it makes it a little bit easier. We know that the slope is 0, and the y-intercept is 4. We multiply, get y equals 0 plus 4, and y equals 4. Whoa. What that means is there is no slope, and the line that we would draw would be a horizontal line. It would look kind of like this on the graph, and it's actually already in standard form. If you wanted to be really accurate, you could do this. 0x plus y equals 4. That would be actual standard form, but regardless, this is slope-intercept form, this is standard form. They're both equivalent. Here we're going to try to create an equation that goes through the points 4, -4, -2, 3. So first thing we're going to have to do is we're going to have to try to find the slope between these 2 points. There's a variety of different ways we could do this. We could plot the points on the graph, then find how the y's change, how the x's change, or you can just compare them as is. So I can see here that my y value goes from -4 to 3. To get from -4 to 3, the y's go up by 7. For the x's, it goes from 4 to -2, which means the x's go down by 6. So the y's went up by 7. The x's went down by 6. So my slope here is -7 over 6. This is how my y has changed. This is how my x has changed. Now we're going to use this information to find the equation of the line. So the slope here is -7 over 6, but we don't know what our y-intercept is. We're going to use this slope, though, to find the y-intercept. So we have an x and a y on both of these points. It doesn't matter which one we plug in. Try to find our y-intercept. We can do either. I'm going to pick this one. So I plug in 3 for y. And I'm plug in -2 for x. And I'm going to try to solve for b. So I multiply both sides. I get 3 equals positive 7 over 3 plus b. Okay? Then I'm going to subtract 7 over 3 from both sides. 3 is actually 21. No, it's not. It is 9 over 3 minus 7 over 3 equals b, which means b equals 2 over 3. So now we have our y-intercept. We can make our equations y equals -7 over 6x plus 2/3. We're going to use this as what form? Well, this here is slope-intercept form. We're going to try to find standard form. First, we're going to add 7 over 6x to both sides. I get y plus 7 over 6x equals 2/3. I'm going to multiply both sides of the equation by 6. I get 6y plus 7x equals 4. And this is my equation in standard form. They are both equivalent, and they're both representing the same equation that goes between these 2 points. Now let's say we're given a line that we know is parallel to this line, but it goes to this point. What does parallel mean? Parallel means that they never intersect, and they never intersect because they have the same slope. So the slope here is -3/5. The difference is we have different y-intercepts. So now we have to find what the new y-intercept is. So we do that by plugging in the points, or the point rather, into our equation to see if we can find that y-intercept. So our y is -2. Our x is -5. We do some order of operations here. Negative is a positive. 3 plus b, subtract 3 from both sides. Then -5 equals b. That's our y-intercept. So our equation is y equals -3/5x minus 5 in slope-intercept form. This equation is parallel to that line because they have the same slopes. They have different y-intercepts, but that doesn't matter. As long as they have the same slopes, they are parallel. Now, I really want to focus on trying to manipulate this equation and trying to put it in standard form because you need to be flexible about manipulating these. So, to put it in standard form, I'm going to do something different this time. I'm going to multiply by 5 first before moving stuff. So I get 5y equals -3x minus 25. Add 3x to both sides. 3x plus 5y equals -25. Notice how I changed the order here. It doesn't matter as long as the x and the y variable coefficients are whole numbers. They're on one side equaling an isolated number on the other side. Manipulating these to get for slope-intercept form to standard form and to other forms is really important. You need to be very flexible with this. So now our final equation we're going to find. An equation of a line. We have to find the line that's perpendicular to it. Well, we learned that the equation is opposite sine for the slope and the reciprocal for the slope of any line that is perpendicular to another one. So that means our slope is actually not negative but positive. That's the opposite sign. And we would do the reciprocal, which is 4/5x plus b. So we know our slope just by knowing the idea of what it means for two lines to be perpendicular. We're going to use that to find the y-intercept. This is my x, this is my y. I'm going to use that to find the y-intercept. So the y equals -2. The x equals -5. I'm going to use this to solve for the y-intercept. Multiply here. I get -4. Add 4 to both sides. 2 equals b is a y-intercept, which means our equation is y equals 4/5x plus 2. But then again, this is the equation in slope-intercept form. How would I find it in standard form? Subtract 4/5x from both sides. I get y minus 4/5x equals 2. Multiply both sides by 5. Get 5y minus 4x equals 10. Is the equation in standard form, which is also equivalent to this, just a different order. Okay? And that's it for different types of equations we can create inside linear functions.